On question 16, we are solving an exponential equation. We always start out by looking at your base and comparing it to the number on the other side, because if they have something in common, you can certainly rewrite them with a common base. In this case, when I first looked at it, I said, oh, they have a base of 2 in common, and I went that direction. And now that I'm looking at it again, you could have also used an 8. So if you want to do that on your own and see that you get the same answers, you certainly can. I went ahead and rewrote 8 is the same as 2 to the third power. And then 64 is the same as 2 to the 6th. The reason that we put -6 is because the 64 is in the bottom of a fraction. And so the way we get a number to go to the bottom of a fraction is we make its power negative. Now, what our rules tell us is that once the bases are the same, then you can actually set their powers equal to each other. So that's what I did on this next step. I did go ahead and distribute the 3 as I did that. So I have a 9x minus a 27 equals -6. And then you're just solving for x. So I added 27 to both sides. That left me with 21. And then I had to divide both sides by 9. Keep in mind that if the fraction reduces, both of these numbers were divisible by 3. Certainly reduce it, so my final answer was 7/3. On question 17, they're asking me to evaluate it without a calculator. So I do need to see work there, even though I know you can hop on a calculator. If it says to do it without, I've got to see the work that shows me you understand your properties of logarithms. So the first thing I'd actually do is take it out of what's called radical form and put it into rational form. So when you have a 7th root of e to the 5th, that's the same as saying you have a e to the power of 5/7. So notice the root goes on the bottom of the fraction, just like if you think about a flower growing above the ground, its roots are in the bottom or below the ground. And then we know with logarithms that if you have the log of some term that is raised to a power, you can actually pull the power to the front. So that's what I did on this next step. And then multiply it by the log of the original term. And then the natural log of e, its value is always 1. So we replace that with the 1. And finally, 5/7 times 1 is simply 5/7. So I do have to see work there. You can't just go from there to the answer. You've got to show me using those properties how you actually get to that answer. Question 18, they are asking you to solve, and they're wanting 2 decimal places. So notice that the x is already on a side by itself. It just has a 7 in front. So really this is just a one-step problem, and then get on a calculator. Divide both sides by 7, and then you're punching it out. And I got a decimal of 0.56. So be sure you practice on your calculator and make sure you get the same thing there. When you see something like number 19, where the x is with your logarithm, then you're going to want to put it in the other form. And when you do that, always start with your base. So my base is 6. It's raised to a power of 2, and then I say it's equal to 2x minus 4. So then the 6 raised to the power of 2 gives me this 36. From there, it's just a simple algebraic equation, and you're getting x by itself. So I added 4 to both sides. That led me to 40 equals 2x, and then divided both sides by 2. So I got a final answer of x is equal to 20. On question 20, I'm asking you to show me your properties of logarithms and expand it out. And so the first thing I noticed is this is a product. 16 is multiplied by x to the 7th. When we break apart a product, we take the logs of each factor and we add those logs together. Then log base 2 of 16, remember the meaning of a logarithm, you're saying what power of this base would give me this number. And what I know is 2 to the power of 4 gives me 16. So I can just say the log base 2 of 16 is 4. And then when I get over here to the log base 2 of x to the 7th, remember with powers you can pull them down in front of the logarithm. So I pulled the 7 to the front, and then it was multiplied by the log base 2 of my x, which was left over.